Hello, today I'm going to show you how I made a portable cooler that runs on batteries and cools your drinks down to 0 degrees anywhere. This project started a long time ago when I got one of these machines that didn't work, which are those machines that make ice. But inside it contained a mini compressor, condenser, evaporator, essentially everything. Since I found it pretty interesting, I took it apart and kept the compressor and the evaporator. Let's say the entire refrigeration system worked. I then found a Tupperware and placed it on top of the evaporator, the cooling component. I filled it with water to see what would happen, to see what temperature it could reach. I was surprised because it worked pretty well. It could cool down to around 0 degrees and was really effective. In the end, we only used it to prepare for Nate up there and drink it, and so it would always be cold. But recently, after I stopped using it for quite a while, I found it and thought, hey, this would be really good to put inside a small cooler. Or cooler? One of those portable ones, so I could take it with a battery and always have a cold drink anywhere. I began searching for the simplest, most convenient one to use. And I found that these metal ones were the simplest and the ones I would be able to work with best. Since I could hammer, rivet, weld them, or whatever, modifying the plastic ones was impossible because welding plastic is ineffective and produces poor results. I found this one, and I don't want to advertise it. It's not like they're paying me or anything. It was the cheapest option, even if it doesn't seem so. Honestly, it's quite good, so I chose to use it. The first thing I did was start taking it apart, and honestly, it was very easy. The inside part was just a sheet of metal that was bent, and you could just pull it up and take it out. And inside it had the insulation, which in this case is expanded polypropylene. The name for this product varies by country. In my country, it's called Telcopor, while in Colombia, I believe it's known as Unipor or something similar. Anyway, it's the most well-known insulation in the world. And it only had a few layers, which are actually quite thin. I don't think this keeps the cold in very well, but, well, it works. It's pretty good. The second thing was to somehow tune the compressor. As you can see, when I connected it, I measured its consumption, and honestly, it had a very low consumption, just running, that's all. 0.2 amperes at 220 volts, and honestly, it cooled very well, but it had a catastrophic problem. I wanted to run it with a 350 watt inverter, something I could handle with a battery. But it had the problem that, as you can see when you plug it in, the current spike goes up to 2.9 amperes, which is almost 700 watts, impossible for our inverter. But we can reduce that spike to just 0.9 amperes. By placing a capacitor of 25 microfarads and 400 volts, which would be about 200 watts at startup. So if we can turn it on without any problems, what we did was optimize our power factor, or cosine of phi. Manufacturers don't consider that in household appliances. But, for example, in a company, you always have to take it into account, because if you don't, the electric companies will fine or penalize you for not doing it. The capacitor is connected to the output of the relay marked with the letter M and to the S terminal of the compressor. There's always a little label that tells you which one is which. As you can see, I installed my Chinese inverter, which is actually less than 350 watts. It turned on and started up very well. In fact, it cooled as if it were plugged into 220 volts. The power consumption was very low. And yeah, this gave me the sense, let's say, that the project was on the right track, that it was going to succeed, let's put it that way. What I did was put it inside the cooler to start measuring the space I had and how I was going to place it. And it seemed to me that the best way was to put it on its side and make a window in the back, which would be where it would go in. The fresh air? This has a cooler that brings the air directly into the condenser. And then I was going to make some holes on the side so that the air, once it's already hot, since the air heats up when it passes through the condenser, can go back out. This is also important because if the hot air stays inside the system, well, in the end, it won't cool. Let's say the system won't work. I started connecting all the components so you don't get confused with so many wires and things. I'll leave the exact wiring diagram on the screen. Is it this one? We'll return to the electronic components soon, as I didn't like it, and we'll explain later. I made some holes on the side and put in some kind of terminals, which is actually just a plastic decoration, just to make it look nice and not leave the hole exposed. And the idea was to put the 12-volt pin for the battery in one and another pin in the other, in case we want to connect it to 220 and not use the battery. As you can see, as I was saying, there were a lot of cables and a lot of things left and a tangle of wires. And, well, anyway, I didn't like it. Everything looked really messy, and I just couldn't stand to see it like that. I didn't like it at all. So what I did was start soldering everything again. I mean, I took everything apart and resoldered it all. On a printed circuit board or on an experimental board, it's not a printed circuit board, but it still turned out pretty well. Everything is close together, compact, in much less space, and with a lot fewer wires. It has multiple sensors, one continuously measuring battery voltage and another measuring temperature, and it has a couple of relays to automatically detect when it's connected to 220, when it has the battery. Anyway, I'm not going to bore you with everything it has. But everything is pretty well thought out, so you can use both options, 220 or battery. I also left the Arduino's USB port accessible so that if we want, we can easily connect a cable and update the fridge's software. By the way, I'm going to leave the software I used in the description, which I programmed myself. And it probably has a couple of things. Let's call it version 1, with room for improvement. So it works pretty well, at least in the tests I did. It didn't give me any problems. I fastened the motor underneath with some bolts to the cooler's metal sheet. The motor doesn't vibrate much. It only vibrates at the start, so this isn't a problem. I didn't use any rubber padding since it's securely anchored, and I haven't experienced any issues with the compressor's vibration. But anyway, once I had everything in place, I started covering it with styrofoam. The whole engine. I started cutting the styrofoam pieces that I got and began putting them on, so they adapt to the new shape, so to speak. And I did the same with the metal sheet. The metal sheet was very thin, so I was able to cut it easily with scissors and even with a box cutter. By going over it several times, I gave it the shape I needed. Then once I cut it, I started putting it back into the cooler. Honestly, it took me a bit of work because on top of that, there were parts I cut that broke. But well, it's not a problem. I think it's just a matter of gluing it. And that's it. And that's actually the part, let's say, that I didn't like how it turned out. I glued everything with silicone and used quite a bit of it, since I didn't want any leaks getting to the electrical components. That's why I sealed everything very well. I made sure everything was completely waterproof so that water wouldn't have any chance to get through, and it turned out well. Don't worry, nothing ever leaked. And now, what I did was put a small 12-volt pump underneath. And this is very important because now I'm going to explain to you why without this pump, the refrigerator practically becomes useless. The refrigerator generates a lot of ice on the evaporator since it gets very cold. And ice is a thermal insulator, so if it fills up with ice, won't it stop cooling the rest of the refrigerator? So what I did was put a small pump that constantly pours water onto the evaporator. And what the evaporator does is transfer its cold to the water. The water falls down, and if not, it will fall on top. But anyway, the water falls, goes back up, and so ice doesn't form on the evaporator until the water reaches 0 degrees. And actually, if instead of using water, we use salt water, the water can go to negative temperatures, and ice will never form. Well, until a certain negative temperature. But I'm pretty happy with the water we put underneath reaching 0 degrees. That seems more than enough to me. Otherwise, the drinks will also start to freeze, and that's not what we're looking for. So basically, it's opening the cooler, filling it with water just a bit at the bottom, up to where the pump line is, let's say, plugging it in and waiting for it to cool. And we did this test with a 12 volt 16 amp battery. And just so you get an idea, at 6 in the evening, the battery showed 11 volts, and a little while later, more exactly, half an hour later, the battery showed 10.9 volts. In other words, only 0.1 volts less. So it could keep running for hours, which also makes it very efficient. Unfortunately, we forgot the temperature meter, but I did the same test later at home. I plugged it in. I measured the temperature and everything was perfect. Ice had formed because the water had already reached 0 degrees. And obviously, if the water goes down to 0 degrees, everything we put in there will also reach 0 degrees. As you can see, the Fernet that was on top was at about 4 or 5 degrees, and the sodas that were at the bottom were also between 0 and 2 degrees. This doesn't really do any miracles, let's say. It's not like it chills the drinks in record time, it just works like a regular fridge, but it cools a lot more than a regular fridge. But with the convenience of that battery, you can take it wherever you want, for example, to a beach or a park, and it keeps your drinks always at 0 degrees. I'm working on future updates or upgrades for this fridge because I think it has a lot of potential, and honestly, it's turning out pretty good. If you enjoyed this video and want to see more, please subscribe to the channel. Thanks for watching, and if you liked it, hit the like button. See you next time.